So say Geronimo, say Geronimo, say Geronimo, say Geronimo, say Geronimo, say Geronimo, say Geronimo.
The goal of elimination is to get one of the variables to have the same coefficient but have opposite signs. This is a really nice starter problem because it basically jumps straight to step 3. It already has my variables lined up for me. X is on top of X, Y is on top of Y. On the other side, I have my constants lined up. When you look at Y, it already has the same number, 5 and 5, and it already has opposite signs. One of them is plus and one of them is minus. That means if I were to go ahead and add these two problems together, the y's would cancel out and I'd no longer have a y term. That's what you want to happen every time. You want one of the terms to cancel out when you add. So when I add these two together, I have 9x equals 18. A really simple one-step equation that you can solve. So to get x alone, I'm going to divide by 9. And I get that x is equal to 2. Now the steps for substitution and the steps for elimination merge because we're going to do the same thing from here on out. You're going to take what x equals and pick one of these equations to plug in x for. So I have 6 times 2 plus 5y is equal to 7. 6 times 2 is 12 plus 5y is equal to 7. Subtract 12 from both sides and I get 5y is equal to negative 5. Divide by 5 and I get y is equal to negative 1. But I'm not finished because I have to write this as a point. My answer is 2, negative 1. Now let's look at some examples that aren't as straightforward. Lucky for us, our variables are already lined up and our constants are already together on the other side. But I don't have a variable that will just cancel out when I add. I do, however, have a variable that already has the same coefficient. What has the same coefficient? X. They both have the same coefficient. So I can make this cancel out by multiplying one of those equations by a negative 1. Which gives me negative x minus y equals negative 6. This top equation remains the same. I was trying to get my x's to cancel, so we need to double check, do they actually cancel if I were to add them? Yes, they do. So let's add the two equations. Negative y plus negative 2y gives me negative 3y. Negative 6 plus 9 gives me positive 3. Divide by negative 3 all the way across, and I get that y is supposed to be negative 1. Take that negative 1 and pick one equation to plug it in for y. So we get x plus negative 1 equals 6, or x minus 1 equals 6. Add 1 to both sides. We get that x is equal to 7. So my solution is 7, negative 1. My x's and y's are already lined up. My constants are lined up on the other side. Do I already have a variable that has the same coefficient but opposite signs? I do not. Therefore, What can I multiply these equations by so that I get that? So to get y to cancel out, I need to find a number that both 6 and 2 can go into. So if I multiply the second equation by a 3, that would give me the 6, but does that give me opposite signs? I need to multiply it by a negative 3 so that they have an opposite sign. So I would get negative 15x plus 6y equals negative 30. The first equation remains the same. My goal was to cancel out the y's. Does that happen? Absolutely. So let's add the two equations together. Negative 15x plus 15x gives me 0. Negative 30 plus 0 gives me. This is not a true statement, so my answer is no solution. We also need to classify this for our homework as inconsistent. For this problem, my variables are already lined up. My constants are lined up on the other side, but I don't have something that would automatically cancel. So select a variable that you want to cancel. Okay, if we're going to get rid of a, what does 5 and negative 2 go into? 10. What would I need to multiply the top equation by to get 10? And the bottom equation? Would that give me the opposite signs I need? Yes. The top equation becomes 10a plus 30b is equal to negative 48. The bottom equation becomes negative 10a minus 30b equals positive 48. My goal was to get my a's to cancel. Does that happen if I add them? Yes, it does. So let's add these two equations. 30b plus negative 30b gives me 0. Negative 48 plus 48 gives me. This is a true statement, therefore there are infinite solutions. For your homework, you also need to classify this as consistent or inconsistent. It is consistent, and every time you classify something as consistent, it can be either dependent or independent. So this is dependent. This problem is consistent dependent.